Why does silly putty act like a non-Newtonian fluid? Imagine stretching a piece of rubber or bouncing a ball, then suddenly watching it flow like honey or break apart like glass. That's the magic of silly putty. It's a toy that's been around for decades, but its strange behavior is actually rooted in fascinating science. So why does it act like a non-Newtonian fluid? The secret lies in its makeup. Silly putty is made of silicone polymers, specifically polydimethylsiloxane, which are long chains of molecules that give it special properties. These chains can stretch and slide past each other, which makes the material both viscous and elastic. When you pull it slowly or apply gentle pressure, the chains have time to move, causing the putty to flow very slowly, almost like a thick liquid. But if you hit it quickly or squeeze it hard, the chains lock together and resist deformation, making it behave like a solid. This dual nature is what makes silly putty a perfect example of a non-Newtonian fluid. Unlike water or oil, which flow the same way no matter how much force you apply, silly putty's viscosity increases with force. This is called dilatant behavior, meaning it gets thicker when stressed. So, if you stretch it gently, it stretches smoothly. But pull it fast or hard, and it snaps or bounces back like a rubber ball. This is because the polymer chains can stretch out slowly, allowing the material to flow, but when stressed quickly, the chains lock up, resisting flow and acting like a solid. It's a bizarre physics trick that shows how materials can behave very differently depending on how you handle them. This is a great example of how chemistry and physics come together in everyday objects, revealing the strange and wonderful rules that govern the universe. So next time you play with silly putty, remember that beneath its playful surface lies a complex dance of molecules that makes it act both like a liquid and a solid, depending on the force you apply.